Okay, this is a problem made by request from somebody in the comments. I'm not quite sure where it came from. I just know it's from a Mock AMC 10. It's a casework problem. In music, a whole octave consists of 12 semitones. C, C sharp, D, whatever, all that. We don't really care. Consist a certain four-note chord to be pretty if all four notes are from the same octave and no two notes are either one semitone or 11 semitones apart. How many four-note chords are not pretty? So these ones are pretty if these things don't happen, so they're not pretty if they do happen. The first thing you're going to want to do in this problem is make a better system of organizing it. We don't care about their names, C, C sharp, and all that. We can just call them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It'll be much easier to think about. I suspect strongly that there is either like a stars and bars technique or a principle of inclusion-exclusion method that you can use on this. I was unable to conceive of the method though, and when I can't do that, I fall back to casework. Again, you just figure it out, even if you're not 100% sure how to do the best way, find a way to overcome. So we will consider cases. Case 1 will be that there are two together and then two separate that are not together and they're not connected to these two. The next one will be case 2 where we have two together and a separate two together that are not next to these two. The third case will be 3 together and 1 separate. And the last case will be if there's 4 together. Now, these are the cases for the first classification of a not pretty tone, which is that they are 1 semitone apart. So if they are 1 semitone apart, that makes them not pretty. These are the 4 cases to consider that. We'll worry about the 11 semitones at the end. So starting out, let's do the 2 together, 2 separate. If you're not sure how it's going to work, just explore it. It's going to work different if the numbers that are together are 1 and 2 versus if they are, 5 and 6, because it has different ways of calculating it. So let's just look at what happens. If 1 and 2 are my block, they're together, they're part of our not pretty tone, then our choices for the other 2 are everything from 4 to 12. 12 minus 4, that's 9 terms, plus 1 is 9. So you're going to get 9 choose 2, but you have to subtract all the cases where they are together. Okay, so 9 choose 2, you would have from 5 and 6 all the way to 11 and 12, right? Actually, I'm sorry, 4 and 5 to 11 and 12. So if I start at 4 or I start at 11, 11 minus 4 is 7 plus 1 is 8. There are 8 ways, because that would actually fall into this category, and we don't want to count those yet. Okay, 9 choose 2, there's a shortcut for n choose 2. If you don't know, it's n times n minus 1 over 2. So 9 choose 2 is 9 times 8, that's 72, over 2 is 36 minus 8. You're going to get 28 ways if you start with 1 and 2 for case 1 to occur. We go to what if you started with 2 and 3 now? Well, you can't have the 1 because that's going to be part of the 3 in a row together, but you don't have access to 4 as a starting point anymore. So it has to be from 5 to 12, which is only going to be 8 terms, and you're going to do 8 choose 2, but this time you have to subtract all the 2's that are together again. So that would be the 5 and 6, 6 and 7, all the way to 11 and 12. 11 minus 5 is 6, plus 1 is 7. So this is 8 choose 2 minus 7. 28 minus 7 is 21. Now what if you started at 3 and 4? Okay, if you had 3 and 4 as your starting point, you now have access to 1. You don't have access to 2 through 5. So you still have 8 terms to choose from, 8 choose 2, but you're not going to subtract 7 this time. That's because I can't have the 1, 2 here. I can only go from 6, 7 to 11, 12. 11 minus 6 is 5, plus 1 is 6. So it's 8 choose 2 minus 6. Again, if you're not sure who these 6 are, it's the combination of 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, and 11, 12. We can't have those because they're part of a different case that we've made. Okay, so 8 choose 2, 28 minus 6 is 22. From here on out, we can use a pattern. That is that 4, 5 will be 22, 5, 6 will be 22, all the way through, so that your last one, the 11, 12 combo, will have 28 again, and the one right before it, the 10, 11 combo, will have 21 like this one, and everything else will have 22. Now, how many of these 2 blocks are there? There's 11 of them, starting with 1 all the way through starting with 11. So if we take these 2 and these 2, that's 49 and 49 times 2 is 98. Plus the other, if you take 4 off of 11, there's 7 22s. 7 times 22 is 140 and 14, it's 154. Add 100, subtract 2, and you will be at 252. So this case 1 has 252 different ways it can occur. Next up, if there's 2 together and another 2 together, let's explore these again. If you start with 1 and 2, then now you can't have 3 and 4 because that would be case 4, but you could have 4 with 5 all the way to 11 with 12. 11 minus 4 is 7, plus 1 is 8. So there's 8 of those this time around. The 2 with 3 is going to have 1 less. It's going to have 7, because you can start at 5 all the way, because you have this block right now. 5 with 6 all the way to 11 with 12. 11 minus 5 is 6, plus 1 is 7. Let's check 3 and 4. 3 and 4, I can't have 1 and 2. I have to start at 6 to 7 all the way to 11 with 12. 11 minus 6 is 5, plus 1 is 6. And this is also going to have symmetry after this point. So you're going to have 8 down here, starting with 11 and 12, 7 here, and 6 for everything in between. So this is 50, 15 and 15 is 30, plus the other 7 times 6 is 42. That's 72. Now, this is where I made my mistake in the comments. I forgot that I've actually counted all of these type twice, because I counted it as 2, 3 is the starting block and 7, 8 is the later block, for instance. I also counted 7, 8 is the later block, and an earlier block was 2 and 3. So actually we've counted this twice. These are the same setup, just I counted them in different ways. So I have to divide this by 2 to get 36 ways for case 2 to occur. We go to case 3. What if I start with 1, 2, and 3? If I start with 1, 2, and 3 as my starting block, I have access to everything 5 through 12 as the last one. That's going to be 8 different ways for it to occur. What if I do 2, 3, 4 as my starting block? Then I don't have access to 1 or 5. I only have 6 through 12, which is going to be 12 minus 6 is 6, plus 1 is 7. What if I have 3, 4, 5? Again, I'm going to have a block of 5 that I don't have access to. Everything from 2 to 6. But I will have 1 and 7 through 12, which is another 7. So this is going to work all the way through to get me to 10, 11, 12. We'll also have 8 ways to do so. So 2 8s is 16. We're starting from 1 through 10. There will be 8 other cases. 8 times 7 is 56. 56 and 16 is 72. We didn't overcount here because these are 3 in a row with 1 separate. We don't have the same situation, 2 together with 2 together. Okay, the last one is 4 together. You can start at 1 through 4 all the way through 9 through 12. So you're going to have 9 of those. Okay, so add up what we got. We've got 108 and 252 is 369. And we need to now consider all the ones that are 11 semitones apart that we did not already count here. Well, the only ones that are 11 semitones apart is if 1 and 12 are part of our set. And so we just need to consider all the cases from 3 to 10, because we can't have 11 as part of the set. That would have been part of this one. The 2 together with 2 separate. That was counted. 1 and 12 with 11 and something else was part of this one. 12 and 11 playing the 2 together block. Okay, so then we have to count from 3 to 10. That's going to be 10 minus 3 is 7 plus 1 is 8. There are 8 choose 2 ways to get my other 2 terms. However, again, we have to subtract 2 together. So, for example, I had 1 and 12 and 6 and 7. This is my four-note set, right? 4 semitone set. Then this is a problem because it was already counted here as well. So how many of these 2 in a rows do we have? You have 3 with 4, 4 with 5, all the way to 9 with 10. 9 minus 3 is 6, plus 1 is 7. 8 choose 2 is 28, minus 7 is 21. We add those 21 ways to the 369, and the answer is 390. I do not know what the other answers were. Again, this was a requested problem. I hope it helps. There's probably another shortcut in here somewhere, like maybe we could have counted these at the same time, or these at the same time, something like that perhaps. I don't want to mess with it. I know this would work, and so I tried it out. I hope it helps. Good luck.